Okay. So my thesis is on permission analysis of Android applications. Since mobile devices are becoming more and more popular, it's becoming security for them becoming a more important problem. So to protect mobile devices, there are a number of different security approaches devices take. And the only focus of the security aspect focus on most of the permission system. Android has a model where when you install an application, it shows you all the permissions that it wants to use, and you either accept them all or deny them all. In iOS, as the application runs and requires permission, it asks the user first. It doesn't see vulnerabilities. I focus on Android because well, first, iOS reviews every application before it goes on the market, and Google allows anyone with a license to upload their applications. And it's difficult to do something that works for both because iOS primarily works with Objective-C and Android works with Java. Then Android uses Java, but it uses a slightly modified version of Java. It shares all the same logic and most of the libraries are in common, except for those libraries involve the user interface and some other kernel level functions. So first, the Android permission system has it. EOS manages Android applications to resources that could hurt the system. And so by default, the Android application has no permissions. The user has to request permission by adding to the manifest file, which has other information about the application. And permissions allow mobile applications to access these additional system resources. There's highlighted 4 permissions that are loaded. So as I said before, prior to installation, Android application must show all the permissions that it wants to use, all the resources it wants to access, and the user either chooses to install the application, accept all those permissions, or cancel the installation, so decline all those permissions. And once they're granted, they can't be changed as long as the application is on the device. So some research I've done, this study by Paolina et al. In 2010 studied 8 popular Android smartphones on the market to see if this model is always enforced properly. And there are several privileged dangerous permissions which are unsafely exposed to other applications, and which means that an application could access these permissions without actually requesting them in their manifest files, which we refer to as capability. And each capability may be essentially a violation of Android security. So applications could do things such as erase user data, send text messages, make phone calls, access user accounts, or obtain geographical location without ever requesting permission. And to facilitate exposing these things, they develop a tool called now they perform this analysis on applications that were pre-loaded on the application, system applications. So these problems can be fixed by the manufacturer of the phone. Then there's a question of third-party applications, which come from the local markets. So application analysis is an important area for future research. Pictures of the 2 stores, the iTunes store for Apple and the Google Play store for Android. The next 2 researchers, I think in all 2011, were the kind of first researchers to use Android permissions as a means of identifying dangerous functionality applications. And they developed here to break down functionality to the set of permissions needed to perform this. Because permissions define what an application is able to do. See my camera?
We want to see.
So permissions define an application allowed to do at runtime once it's installed. So they found this to be a very important way of knowing malicious applications, defining what malicious applications. So they used this to analyze 311 popular applications on the market. across different categories of the market. And only 10 applications were flagged as possibly dangerous, and only 5 after reviewing their purpose. So now I want to talk about the principle of least privilege, which essentially means an application should only have the permissions that it needs and no more. So for example, if you want a text messenger to be able to access your contacts and write to them, but you don't necessarily want it to access your location or past that. There are some problems to enforcing this. One is that it can't be too permissive or too restrictive. If it's too restrictive, then your application will generate errors when it tries to access something it doesn't have permission to. You don't want to be too permissive, otherwise it violates the principle of least privilege, and the program can be exposed to security attacks. So as next seen, Felt et al. Studied Android applications to determine if developers actually follow this principle, or whether they overprivilege their applications. And to do this, they developed a tool called Stowaway, which is a static analysis tool, which I'll get to in a bit, that detects overprivileged applications. And applications considered overprivileged, it's composed of 2 parts. One breaks down the application into the API calls that it's using and uses a permission map that identifies those permissions required for each of those calls. So based on this, it calculates the maximum number of permissions that an application needs, and it's compared to what the application is actually requesting. So the application requests more permissions than is considered overprivileged. And this is just a screenshot of part of their permission map. They'll list a couple of API calls and the permissions that are required for each of them. And this is a very lengthy list. So what are the causes of overprivilege? So they applied Stowaway to 1940 different Android applications on the market. Out of this, they found that only roughly 1/3 of them were overprivileged. And they also found that the majority of these were only overprivileged by a few extra permissions. And what they kind of found was that developers generally try to follow the principle of least privilege, but fall short due to documentation errors or lack of developer understanding. So it kind of supports the effectiveness of this install time permission system. Here's just a picture of the tool, which is on the website. You can upload your app for analysis or look at the permission map. And I uploaded a very simple application that doesn't actually do anything, perform anything. So the application was overprivileged, but it just suggested that it have these extra permissions based on its API calls to read contacts and access the network state. Since the application doesn't actually serve much purpose, that would definitely be overprivileging it, but the application itself isn't. So now that I mentioned stack analysis, let's talk about what stack analysis actually is. It consists of building a model of the execution program without actually executing it. The benefit of this is it's sound, meaning all permissions that it will require will be found, but it's also kind of conservative in that it may report extra permissions, as I kind of showed. So, like I said, it's kind of a pro in that it'll capture everything as long as you keep in mind methods, reflection, callbacks. There's no need for test case configuration because it's modeling the application and safe. By safe, I mean it's not actually executing any code, so it can't execute any malicious code. On the other hand, well, it's unsafe. It's unsound if you don't keep in mind native methods, reflection, callbacks, and it can lead to false positives. Some area of research on stack analysis, I mentioned Stowaway already. This other team, Thesis, all created a stack analysis tool that aids the developer in accessing appropriate permission requests. And this other team, Gilmore, developed Android leaks to find potential privacy leaks in applications. So, talk about stack analysis, and it's Kind of has a dual analysis called dynamic analysis, which is actually executing the program. It's not conservative in that everything that it reports, it won't report any extra permissions. Everything that it reports will be necessary, but it may not capture all of them, depending on how much you test. So, this row, it's completely gives you the maximum permissions it needs. But it requires all this test casing configuration, and you can even actually, you may unintentionally run malicious code. There hasn't been much dynamic analysis in terms of permission analysis, but there are some dynamic tools out there for other aspects of Android security. Pretty much all of them being extensions of this tool Android that Anchor developed and is used to identify privacy-sensitive information through the network. Paolina extended it to characterize privacy exposure, and then Gilbert extended to track specific types of flows and discuss other approaches to application analysis. Now I want to talk about combining the two, which is a novel idea for Android export. Manual code inspection is reasonable for small programs, but for lengthy problems, it's kind of tedious, time consuming to prepare for. We talked about the pros and cons of dynamic analysis and static analysis. But as I mentioned before, they're kind of a pair. Static analysis doesn't report any false negatives, and dynamic analysis doesn't report false positives, but they do report the opposite. So, these kind of counter each other. And if you run the dynamic analysis with the results of the static analyzer, then you remove the need for test casing and configuration. So you're kind of left with the complete analysis, the complete part of the dynamic analysis, and the sound part of static analysis. Some previous work. This, Centonze made a tool for Java applications called Ace4j. This is kind of the window of the tool and Java's policy file with a couple permissions that this particular Java library requires. And for my research, we're basically extending this to Android since it's a similar kind of system. So my tool, Ace for Android, is a dynamic tool which we ran with a static analysis tool such as Stowaway to test Android applications for to validate the permissions that the Android application needs. And the result will be this precise, complete set of permissions that the application requires to run time, no more, no fewer. This kind of screenshot of my home screen. It'll present a list of all the applications that are on the device and allow you to choose a class. It'll then retrieve the manifest file from the application and wipe away all its permissions. Then you have a couple of options. The first kind of be to form. I say we'll retrieve the manifest file. So here's the manifest file of a Hello World application, and here's the same manifest file without this permission. Next, you can choose your methods. So this is a list which scrolls down of all the methods found in this particular class, and you can choose a set of them to run the analysis on. Android sandboxing applications, unless it sets up a receiver with other applications, and this prevent malicious activity in the system. if applicable, the user needs to define what parameters are required for a particular method, and then you can actually invoke those methods to see what permissions are required. And when a permission is required, since we're removing the permissions, the security exception will be thrown and reported in the logcat file. The logcat file is Android's own kind of mechanism for reporting all application activity. When you're done with your analysis, you can deny or grant any permission found in that file. So here's a security exception. The internet permission was required when it was supposed to crash the application, and it captured that permission here, which you can add to your new manifest file. Some obstacles I encountered while doing this. One, to start off, was learning about Android permissions and how the system handles them, how they're granted. Another part was learning Android development, since prior to working on this, I hadn't studied Android programming before. And then, as my researchers had mentioned before, the system isn't always enforced properly, which could mean that depending on the device, it may find permissions that the application doesn't actually need to run the system. And it's only a problem for it catching a permission, because if the application leaks permission, it's not necessarily going to be caught with a security exception. So that could be a problem. Haven't encountered that yet. And the other team mentioned that there are common developer errors due to poor API documentation and poor lack of, poor API documentation, which could be a problem. And a major difficulty for me was the difference between Java APIs and Android APIs. I was kind of modeling the tool that Dr. Centonze created, but a lot of it had to be scrapped and rewritten because of the differences in the Java libraries and the Android libraries. And then the big thing is that every Android device has a slightly different version of Android. It's open source, so manufacturers can kind of tweak their own version of Android. Why is this relevant? So as I said before, Android and iOS are different, and that they use different languages, and they use different security models. Android uses this permission-based security model. iOS doesn't really have an explicit permission system. It just uses permissions. Android is open source, while iOS is highly maintained by Apple. And Android is the only platform that allows flexible communication between applications. So permissions become one of the primary areas of security and vulnerability, and this method should help users be aware of mistakes they make in defining permissions in their applications. And this thesis has been submitted, accepted, and presented at Master's Level Graduate Research Conference up in Rockport a couple weekends ago, and paper's been submitted to the 24th International Information Management Association Conference, which will be here in October. And conclusion, ACE4A will enable Android application developers to verify their applications and make sure that it's running securely and properly at runtime. And it's important for application developers to choose the right set of permissions, underprivileged or overprivileged, before applying to ACE4A. So now I'm actually going to demonstrate my application functionality, even though you've seen screenshots.
Extra set of hands?
No, okay with this.
Sit down.
So I preloaded my application as well as my Hello World test application. I'm going to basically perform the analysis on that. So first we can view the manifest file. It doesn't have any permissions at the moment, so there's no difference between the original manifest and the new one. We're going to choose two different methods. This includes all the methods I defined and all the methods that an Android activity inherits. So there's a lot of. But we're going to choose the print hello world and print to Facebook. Oh, actually, let me show you the application. It simply just prints hello world or another message onto the screen, and it allows you to share that information to Facebook just so that it has something that requires your permission. So you can see on the top I have that is the class, and these are the methods. So I'm going to print hello world allows me to put in any message. Allows me to vote it says the bot that is successful. And then and then to print to Facebook will actually require the internet permission. It's also successful. So now when this is, as I mentioned, is the login file, which as I said monitors everything, so it's quite lengthy. Here you'll see that the print to Facebook caused this fatal exception that requires the internet permission. So it's reported over here. Oops, what did this happen?
Oh.
Okay. So you had a question? Or?
No. Almost worked.
They captured that it required the internet permission. And yeah, so basically it will appear in the manifest file. Since I said the permissions can't be changed as long as it's installed on the device, so what will then have to happen is it's saved to the SD card, and the software, the application developer can replace their copy of the manifest with one that this application creates. And that's basically how it works. Any questions?
Well, if you're doing dynamic analysis, you basically have to, I mean, if you want to be thorough, you have to test pretty much every execution path, you know, to look for any permissions that might be required regardless of the particular, the way a particular user is using your application. And I guess most of the applications for the Android would be event-driven, right? Depending upon how a user interacts with it, there's going to be a different stream through a program.
Right.
So you have to look at almost every possible ordering of events. Is that right?
That's correct. I sort of kind of glossed over the combining of the two analysis. Basically, how this is supposed to work is you'll run it through the static analyzer. Right now, I'm proposing Stowaway for the meantime, and run the dynamic analysis based on those results.
Right.
Everything. Ideally, this will end up becoming a tool that has both static and dynamic analysis, so that all that's kind of done automatically. But yes, I mean, for the dynamic analysis to work effectively, it has to model execute everything that can possibly go on.
Which is theoretically impossible. I mean, there's an infinite number of such, depending on the data, you're going to get a different possible execution path. So, how do you handle it? Do you set some upper limit on the number of paths that you consider?
Well, the number of paths you choose is really the number of methods that the user invokes. The dynamic analysis is kind of dependent on the user actually choosing their paths.
So the user gives you some input,
Right.
and then you're going to check. You'll check the path that is required for that input.
Right.
And if they want to check again with different input, they can. But so it's exhaustive only in the sense, or only to the extent that the user gives you a case to test.
Right.
So you're not saying that every potential path has been exercised.
Yeah. Plus the study analyzer will help a lot what type of good inputs, guess inputs the user needs to input in order to have a finite, set of permissions, because as you mentioned, it would be like almost an infinite possible, but the study analyzer will come to a conclusion of a finite sets, and based on that finite sets of permission, then the study analyzer will do that with the dynamic analyzer, kind of validating, right? Because the static analysis is going to be conservative, reporting all the possible,
Right.
and which is very possible. Some of those permissions are not even required. So that's the reason you intervene with the dynamic analysis. Say, now let me test them, let me validate if all those permissions that the study analyzer is actually reporting going to be actually needed at one time.
So after doing the static analysis, does the person using the tool get some feedback about what sort of input they ought to do in order to do the dynamic testing?
So right now, not exactly, because they're two different tools. What Stowaway does return is the permission, well, actually it's small now, but it returns the permissions that it thinks it needs. Well, first it diagnoses if it's overprivileged or not, and then it will assess if there's any additional permissions it thinks it requires. And as the developer, you basically have to choose, well, you do your tests on your application based on what these permissions are to see if they are extra.
So you sort of have to think about
Yeah.
if it's telling me that it thinks I need those permissions, then I have to think about what sort of input I might put in that would require those inputs.
Yeah, the permissions are very intuitive, like they are very in English, like internet permissions or contact permissions. So you kind of test those type of, the user will input those type of inputs that are related with internet or that are related with some storage, files. Right? You want to say more or?
Basically, can't cover it.
So this would be mostly, this tool would be, or this combination would be mostly useful for a developer.
Right, the actual developer of the application.
So somebody who's familiar with the code and would see if Stowaway is telling me that I need this permission, I would know based on the code that I've written what execution path I need to test.
Yeah, and also for not only for the for a developer, but also for any industry or any corporate wants to buy a huge, very good Android-driven application, and before actually installing and spreading across the corporation, they wanted to test how safe is that application is before actually I let it to the to my employees to use it. If it is accessing some private resources, I want to make sure it is very tested and it's doing the things that it's supposed to do without violating any security issues. So it can be from both, for a developer point of view, or also for, corporation wanting to buy, this type of Android application, and before, giving to the other employees to use it, they have actually tested.
Would it be correct to say, though, that if in that kind of situation, like a corporate person, corporate client, who wants to test an application, that the static analysis would be more useful in the sense that it would be conservative, right? But I wouldn't need to know anything about the code. In other words, the tool would tell me everything that I would need to know. Whereas to do the dynamic, I have to understand the different execution paths through the code in order to supply the correct test case.
Yeah, you wanted to have, the best solution is really to have, you can answer that? Can you answer that?
Well, another thing, yes, because one of the kind of prerequisites to using the tool is you have to know its classes and methods. I can supply all the applications, but there's really no way to make a list of all the different classes that application has. In a manifest file, any class that accesses the UI has to be named, but any other class is left out of there. So basically, for any of your objects or anything, you're not necessarily going to know their names. You kind of have to supply the name. So anyone can use it, but you kind of have to know what the capability of the application or functionality of the application actually is. So I don't know if that's a better picture of.
Yeah, it seems that like if you think about a naive user, they're probably not going to have the wherewithal to use all of that information. I think for a naive user, if they got some assurance, if there was like a credential that said, the developer has done this, and it's been certified, then you would feel confident in using the application. Whereas trying to do it yourself might be too difficult.
Yes, it would be hard for a naive user to actually be able to test everything. It would be definitely more beneficial for the actual developer again.
Yeah, and as I say, if there was kind of a certification, if you got
that would make sense. Any other questions?
I don't know if it's a relevant question. Now that you have a dynamic on top of the static, right? So if someone wants to play smart and puts a function with nothing in it, just to prove that he's using a permission, when running the dynamic, you will make sure that it's doing something, right?
Exactly.
And that's why I don't think it's relevant. If someone wants to play smart, right? Yeah. And puts a function that uses a permission just to show that he's using the permission, but inside of the function there's nothing. So the dynamic would come on top and run and see if it's doing something. And
if it's actually required, yes.
It's good.
If the function's ever called, the dynamic analysis is not going to see it. The static analyzer might not get it.
Yes.
But if it doesn't do anything and it's never invoked, then the dynamic analysis is not going to see it being exercised.
From Sova's point, it sees an API that requires permission. It's going to say, we think you need this, but like I said, it's never actually used, and it's not going to come back. That's it.
Just a general word, I'd really like to thank all of the students who presented today. You guys did a wonderful job. I think all the projects were really valuable and exciting. And I think you should feel very proud of yourselves for the work that you did. And I'd like to congratulate